So good afternoon, everybody. My name is Kayode Emmanuel Doing, and I'm going to be talking on doing cool stuff in robotics using ROS with Python. So I know a lot of you might, at one point in time, be like me, whereby you have a robotics idea that you feel like taking on. But when you go online on how to execute that idea, you find out that there are lots of complex stuffs, there are lots of complex algorithms, there are lots of complex process that you find out that you think this particular idea is impossible for you to take on. But don't worry, I'm going to give you guys a tool which is called ROS, Robot Operating System, that help you simplify all those processes, all those complex, that you don't need to worry about all those problems. All you need to focus on is the problem you are trying to solve. So I'm Kayode Emmanuel Doing. I'm a graduate of Systems Engineering, University of Lagos. So during my course during my course of study, I was involved with Coderina. It's an NGO. The full meaning is Coder in Africa. So what we do is we teach secondary schools kids robotics using the Lego 2 kit. And currently, I work with Team Apps Limited. Is a fintech at Lekki where we create financial happiness. And during my free time, I involve myself in couple of robotics projects, which is the autonomous mobile robots. That was my final year project. It's a very, very interesting project and taxing project. That project really challenged me a lot. Also, around June, July, I was also involved in a competition in Ethiopia. It's a robotics competition organized by ICOG whereby you have to build a robot that plays soccer. I was involved with some team from the University of Lagos at Ethiopia. And I'm currently exploring on the technology for self-driving cars that are suitable in the Nigerian environment. Meanwhile, because the Google self-driving car, you can't bring that car to Nigeria to drive itself, and it's definitely going to drive. Is it? So, because Nigeria users, we are all unique. Like we are, if you bring a product from outside and bring it to Nigeria, at least to some degree, that product will definitely fail. Because Nigeria users, we are unique. So, quick one. The theme of this year Python Nigeria conference is building the universe we love, right? So, how many of you can imagine a universe you love without artificial intelligence being in that universe? Really? Okay, so if say artificial intelligence is in that world, can you imagine that world? Can you imagine that world with artificial intelligence without moving parts? So so that brings us to robotics. So when you take that artificial intelligence and that moving part, you have robotics. That's just it in basic. So I don't want to go into in depth of what robotics is all about. I know some of my colleagues that spoke, they've done justice to that really. But basically, a robot just has pre-process. Hello. So if those three processes are not there, you can't call that system a robot. So the first one is input. You have to be able to get inputs from the surroundings. Hello, you need that robot has to have sensors to be able to get data. So the second one is processing units. Those data, those inputs that the sensor gets, you have to be able to process them. And the last one is output, whereby the result of that processing is used to affect the world. Hello. So any system that does not have these three units, it's not a robot. So let me ask a quick question. Is a photocopier a robot? So let's move on. So in as much as we feel in as much as robots are very, very easy. So because it is by the year 2025, it is expected that the global spending on robotics will be 66.9 billion US dollars. And currently it is between 15.1 and 26.9 billion US dollars. And Nigeria, it's not even contributing any at all. So it means we have a problem. So we need to add all those our money that are just hanging everywhere, that Python are swallowing. We need to invest them in robotics, guys. So also robotics has two units. The first one is the hardware. So currently there are lots of hardware in robotics, like lots of them. So the problem of hardware has been conquered a long time ago because there are, when you go online and you Google robotics hardware, lots of sensors will come out. We have the leader, lots of parts will just come out. But there's one problem. How do you combine all these parts together to make something cool? So that is where the robots programmers come in. So in Nigeria also, we lack robots programmers. So because when you look at the gap between robots programmers and other programmers like the web, Django, machine learning, artificial intelligence, like the gap is just like, I can't even fathom it. So it means we have a problem somewhere. So that is why we can't see people coming up, providing solutions, providing a robotic solution for our agricultural sector. We can't see people coming up that will say, oh, this issue of Boko Haram in the north, we have a robotic system that can help you do a proper surveillance to solve that problem. We don't have people coming up that can solve the traffic situation of Lagos State because it's only because I've been to some couple of states, but not much though. But I found out that Lagos has a lot of traffic. Like why can't someone just come up like, oh, let me develop this drone whereby I can deploy this drone to some strategic locations in Lagos State and this drone reports data back to me in real time, which I can use to plan my route, my route, where to take and all. So so that's where ROS comes to the rescue. So you have this big project that you want to do, but you don't know how to start. So the good news is that ROS is the standard for robotics. There's no robot that you will find out there that does not use ROS. It's impossible. Like the ratio of robots that adopt ROS to the ones that don't use ROS, it's like very far. So what is ROS? ROS is a flexible framework for writing robot software. ROS is specifically made for ROS. ROS is specifically made for robots. And mind you, ROS is not an operating system. It's not an operating system because it sits on top of your operating system. So, it just leverages the resources from the operating system to coordinate its own activities to control the robot. That's what it is basically. So it's a collection of tools, libraries, and conventions that aim to simplify the task of creating complex and robot behavior across a wide variety of robotic platforms. Like I said, a lot of robots use ROS. So when you have a particular problem because robotics problems are usually very complex. One person, a group of team, a laboratory cannot solve a particular problem in robotics because the problems are very, very, very complex. So we need to share ideas. So how do you share ideas if you don't have a unified framework that you use to program your robot, a unified framework that team A and team B can understand effectively to share ideas. So why do people love ROS? Like why are people downloading this software and using them on their robots? So like I said earlier, creating truly robust general purpose software is very hard. Like very, very, very hard and complex. Like you spend hours trying to just figure out how to move things. Because things that we feel like as humans is very easy for us. When you tell a robot to perform it, that's when you just see things like this will just be moving like this will be going like this. Because they are very, very actually they are very complex tasks for robots to perform. So dealing with this eventually, like I've said this earlier. So this is a chart of the total download of ROS. ROS was created in 2012 by Willow Garage, I think at MIT. So a group of guys just comes together that, oh, why can't we build? Because there was this problem. When people want to build a new software for robots, you need to always start from scratch. There are no codes that you can actually leverage on to solve your own, because when you have a particular problem, normally, thank you very much. Sorry guys. So this is so when you have a particular problem, normally you are supposed to face your problem and leave what and don't focus on problems that people have already solved. So because in robotics then people tend to like, oh, maybe you want to control a wheel of a robot, you have to write code from scratch to control that wheel. Maybe you want to move a mental arm, you have to write code from scratch to move a mental arm. But then what enables you to do is that there are packages already that people have already written that can do all those tasks. All you just need is that leverage on those packages and solve your own problem and face your own problem. So let's move on. So, these are the features of ROS. The first one is distributed computation, because a very robotics complex has a lot of processes. You can have as little as one process to as complex as 1,000 processes running together. So ROS has this communication layer that helps you to manage these processes together. So the second one is rapid testing. So testing a robotics platform is time consuming and is error prone. But then ROS has simulators that can help you model, whereby you model the real world and simulate it in ROS. Also, we have what we call playback, what we call bag. It's a way for you to play back sensors. Okay, let's say you go out to go and get data for your system. You can actually play those data back into ROS to develop your algorithm. So those data they are just there for you to use for testing. So the second one is software reuse. So how many of us have seen this latest ad from GitHub? How many of you? So this is actually what ROS enables. ROS enables software reuse, whereby I've said earlier, you don't have to concern yourself with problems that people have already solved. You can actually leverage all these packages. There are like thousands of packages that are cut across different fields in robotics that people have actually developed packages from that. All you just need is just do sudo apt get or sudo apt install this particular package. Then call it from your Python script and that's all. And the last one, it's open source. Like it's just free for you to download. You don't pay a dime to use ROS. So this is just a short video of some of the robots that are using ROS currently, and the laboratories and the type of problems that they are trying to solve with it. So what is ROS concept? So for you to be able to use ROS, you have to understand some particular concepts. So ROS has three main concepts. So and I'm going to try and explain them for you, so that when you want to go on your own to start using ROS, it's going to be very, very easy for you guys. So the first one is the ROS file system. So basically what ROS file system consists is we have packages, meta packages, package manifest. And what is a package? A package, you know, like packaging, you just package something like this. So packaging is just a software that performs a particular function that maybe a group of, maybe a lab or a research team have written, and they just push it to the ROS repository publicly for people to just download and use. So what is package manifest? Package manifest is a general description about that package. So we also have the ROS community level. So ROS has different distribution and different versions. So currently, the latest version of ROS is the Bouncy. It's called Bouncy. So when you guys look up ROS, you'll be seeing Tortu everywhere. Do we know Tortu in Python? You've not used the Tortu in Python before. Okay. So you'll be seeing Tortu everywhere. So ROS adopts this Tortu and use it as their logo often. So we also have the ROS Wiki, which is a very good place for you to get lots of information about ROS, of how to start using it. So let's move on. So the ROS computational graph level, this is where people usually get it wrong, because if you don't understand this particular concept, this particular terms here, then you will not get the whole idea of ROS. So let me just quickly just demystify it for you guys. So let's take a newspaper, right? Everybody we know what a newspaper is. Sorry guys. So we have a newspaper. We have people that publish newspaper, right? So we have Daily Times these days. They are all different vendors that. So they are all different publishers of newspaper. So and we also have vendors that can go to all these different publishers and get newspapers from them. And we have the consumers. We can just go to a particular vendor and request for this particular type of newspaper. So that's scenario. So let me just use these terms from the ROS computational graph to explain it. So note, what is a node? So in a robotics system, you have different processes. You have a process that can take data from the sensor. You have a process that can process that data, and you also have a process that can move a particular part in the world. So those processes, they are nodes in ROS. They are nodes in ROS. So the second one is the master. So the master coordinates all their activities. Master coordinates all their activities. So master has information about all the nodes. So when one node wants to communicate with another node, they go to the master to get information about that node before they can send data to that node. So and the master is like the vendors that goes to different publishers to get newspaper from them. So the people that are published in the newspaper, they are nodes. The master is also a node itself, and with the consumers that go to different vendors to read paper, we are also nodes ourselves. So the next one is the parameter server. Parameter server is just a server where you store information that is required by all nodes. So the next one is messages. So what is a message? Also, let's take a camera for example. Look, let me just paint three scenarios. We have a camera that takes pictures. We have a process maybe to detect a ball, and it sends commands to a particular motor to move towards the ball. So what are they sending from each other? So the camera sends images to that processing unit to process. So that processing unit sends a particular, maybe it just sends to that wheel that, move 3 centimeters per second, move 4 centimeters per second. So that image and that 3 centimeters per second, they are messages in ROS. So you can have different type of messages. You can have a message so messages are typically data structures, basically. They are typically data structures. So what are topics? So those nodes that are sending stuff from one point to another, they have to send it to a particular topic, whereby a node that require that information will subscribe to that topic. So there is this concept of publish and subscribe. Publish and subscribe. So this particular node publishes data, and this particular node subscribes to that data. So different nodes can subscribe to a particular topic, whereby one data is publishing to that topic. And we also have services. So services are two nodes, whereby a client sends a request to a particular node, and that node must always give a feedback. So let's take for example, a robot wants to move from point A to point B. So you send a command to that robot to move up from point A to point B. So, but as that robot is moving, the robot has to give you a reply that, I have gotten to point B. So in that scenario, you use a service client, because you have to have a feedback from that robot that it has gotten to that particular point B. So we also have bags. What are bags? Bags are just sensor data that you can actually play back. So this is just an example of how a publisher node and a subscriber node is in Python. So once you have ROS installed on your system, all you just have to do is import through ROS-Py. Once you import through ROS-Py, you can also import a particular message of your choice. There are different types of messages that you can import. We have string, we have image, we have sensor data. And when you do that, you create your node. So this node takes two parameters. We have the ROS-Py.init underscore node. It takes two parameters. The first one is the name of that particular node, and the second one is anonymous equals to true. Don't let me go too much into that detail now. So the next thing you do is you create a publisher. So this particular node now is a publisher. It means what? So this particular node is going to be publishing a particular data. So, and this publisher takes three parameters. The first one is the topic name. What is the topic name that you want to be sending that data to? And the second one is what type of message do you want to send to that particular topic? And the third one is what is the size of data do you want to be in the queue of that topic? So we also have the ROS Features. How long do you want to be sending data to that particular topic? So that is this misfire. So, and likewise we also have the subscriber code also. You can just go through it. I'll give you guys this stuff. So ROS also gives you a way to know how all your nodes are connected to each other. So this is just a simple one, and they can be as complex as this. So with this you can monitor nodes that are in your robotic systems. And mind you, because normally in a robotic the way it is done before, when a particular process is not working, the whole application won't work. But with ROS, if a particular node is down, your system still keeps working. So, and ROS has a tool we call that integrates with Gazebo. So Gazebo is a simulator. There are lots of robots that you can use to practice. Even though you don't have money to purchase that $1,000 sensor out there, you actually learn about those technology by using the Gazebo simulator. And the Gazebo simulator is free. It comes installed with ROS. So, and how do you start using ROS? There are three ways. The first one is by using a virtual box, whereby you download an image that has ROS installed, and then you run it on your virtual box, so you have ROS on your system. And the second one is by following the ROS wiki, whereby you install ROS on your system itself. And the third one is by going to a particular site from the construct. So the way this works is that, because normally ROS runs on only Ubuntu, which is ROS 1, but there's ROS 2 that runs also on Windows, but it is still in the development stage. So using this ROS DS, all you just need is just go to their site, register there, then you start using ROS. But at one point in time, they start charging you. So let's leverage the power in ROS. Our words depend on that your robotics ideas/project. I'm Aseginelo. Thank you. It's a word I learned in Ethiopia.
Thank you.